Depth sort algorithm is one of the most important visible surface detection method. It's a combination of object space method and image space method. We know that in object space method, it compares objects and parts of the objects to each other within the scene definition to determine which space surface is visible. And in the case of image space algorithm, visibility is decided point by point at each pixel position on the projection plane. Here, two basic functions are there in the depth sort algorithm. First one is surfaces are sorted with a decreasing depth value when you have n number of surfaces. And surfaces should be scan converted starting with the greatest depth or set value. That is, we are given a set of polygons in 3D space and a viewing situation, and we want to render only the visible surfaces. And it's also known as a painter's algorithm. Here you can see a beautiful scenery, and it consists of lot of things. And painter starts his painting the object which is farther and the next one, and last he will paint these things what we are seeing in the foreground. Here, while painting, the objects may overlap. The basic idea of depth sort algorithm is painter's algorithm. That is, painter is creating a picture by drawing the background scene first. Here in this figure, first one, initially the paper is put here and he has drawn this one, that's mountain, and next one, this one, he is going to draw a house, and then this one he has completed the house, and then he is started to draw a tree. Next one, he completed all the pictures. That is, first one this one, next this one, next this one, next one, next one, and finally he has painted this one. Same thing is doing in the depth sorting algorithm. That is, surfaces with the greatest depth value, set value, will be scan converted first, and the next one having smaller depth, and continue the process, and the last one is doing the scan conversion which is having the least depth. Here, first draw the distant objects, then the closer objects. Pixels of each object overrides the previous object. Here in this figure, this one is first one, then second one, third one, fourth one, fifth one, and sixth one. First one is completed, then the second one, then third one. Here it is fourth one is completed, then fifth one, last is the sixth one. After completing the sixth one, it has been overlapped this second and third. We cannot see the second and third surfaces. Here in the depth sorting algorithm, the idea is to draw back to front, drawing of all the objects into a frame buffer. Surfaces with the greatest depth will be scan converted first. If there are n number of surfaces, each and every surface should be scan converted. The algorithm says that in the first step, sort all polygons based on their farthest set coordinate. Next one, draw the polygons in order from back to front. Here, 4 test cases are there. Test case 1, the boundary rectangles in the xy plane for the two surfaces do not overlap. Second one is, surface S is completely behind the overlapping surface S dash relative to the viewing position. And the third test case is, overlapping surface S dash is completely in front of S related to the viewing position, and the fourth test case is the projections of two surfaces onto the viewing plane do not overlap. If four test cases fails, then we'll go to reorder the surfaces. Let us see this one. Suppose the test case 0 is there is no depth overlap. Depth overlap means in the Z direction. In the Z direction there is no overlap. If the test case 0 fails, go for the test case 1. That is case where there is an overlap. And also if the test case 1 fails, go to the test case 2. If the test case 1 passes, stop there and scan convert the surfaces. And continue the process up to test case 4. That is, if test case 2 fails, go to test case 3. And also if test case 3 fails, go for test case 4. If test case 4 also fails, we need to reorder our surfaces. See, here test case 0. That is, there is no overlap in the Z direction. This is X direction, S axis, and this one is Z axis. Here two surfaces are here, S dash and S. Then this is Z max and this is Z min, and we are representing this one as Z dash min and Z dash max. Here there is no overlap. You can see this. Suppose if Z min is here, that is Z min is less than Z dash max, there may be overlapping. There will be overlapping. Here no overlap in the Z direction, so it is test case 0 passes. Suppose if test case 0 fails, that is if there is depth overlap. Depth overlap means overlap in the Z direction. Here you can see, if you are depicting this one, there is overlap. So here put the vertical line to the X axis. Here we can say this as X dash minimum, X dash maximum, and here S minimum, X maximum. Here in the X direction, X axis, there is no overlap. There is no overlap in the X direction. That is, there is no overlapping along, there is overlap in the Z axis. We can see this one. Then there is no overlap in the X or Y axis. So go for scan conversion of S and then S dash. Suppose if X min is less than X dash max, this one, if X min is here less than S dash max, then there will be X axis overlap. Then there is a chance of overlap. So test 1 fails if there is overlap along X or Y axis. If there is overlap along X or Y axis, the test case 1 fails. Then what do we have to do? Then go for test case 2. Here is test case 2. All points of S, this one, all points of S is inside S dash, this one. So S is completely behind S dash. This S is completely behind S dash. Then in that case, take the plane equation AX plus BY plus CZ plus D is equal to 0. And take a point S, XYZ in S. Take a point XYZ in here in the S surface. And it should be substituted in S dash plane equation. S dash plane equation is this one, S plus BY plus CZ plus D. Then I have to take all the points of S, that is XYZ point, and substitute that value to the equation of S dash. Then you may get two outputs. If the output is less than 0, it indicates that the point is inside the plane. If the value is greater than 0, it indicates the point is outside the plane. Suppose if the value is equal to 0 means S is equal to S dash. Same line, same surface. Here all points of S is inside, so S is completely behind S dash. You can see S is completely behind S dash. Here is test case 3. Here S dash is completely in front of S. S dash is completely in front of S. But in this case, we cannot say that S is completely behind S. And the test case for the test case 4 does not fail. You can see this green color rectangle is represented as plane. Here one plane is there. Here also another plane is there. Then the yellow colored one is projection surface. This is also projection surface. Now you can see that the projection surface does not overlap. The plane overlaps here, but the projection surface does not overlap here. So test case 4 is successful. Here in this example, you can see that this test case 4 fails. That is, both planes are overlapped here. Also, projection surfaces are also overlapped here. So, the test case 4 fails. In this case, test case 1, 2, 3 and 4 also fails. So, what we should do? Then we should go for reorder the surfaces. That is, S dash should be scan converted first, then S should be scan converted in the reverse order. So, thank you.